Hello there and welcome back. We are still in Module 1, so we're in the inquiry section. We have covered investigation design. We have covered how to analyze research. And now we are looking at how to evaluate our results. And we have some more terms. Again, I know this is monotonous, but once we get through this lesson, we'll actually be doing a few more things. In the next one, we have some graphs and things to look at, so it hopefully will be a little more exciting. But in this one, we have 5 more terms, and let me highlight those for us. We have analyzing data, bias, conclusion, evidence, and reliable. And you probably have heard of all of those except maybe bias. Bias is one that we don't hear a lot. And on this one, I'm just going to go down the list. I am going to say that for conclusion, we've already done that one, so we're not going to write that again. I'm going to refer you back to what page is this? Page 6. So I'm just going to say, see page 6, there is no need to write this one again. I didn't realize that I had duplicated it, so I'm sorry, but we won't write it twice. So we just have 4 terms to define here, which is fine with me. Okay, analyzing data. This is the process, step by step. It is not haphazard or random, of inspecting, which is a word for studying. If you inspect something, you're looking at it very closely. Inspecting and interpreting. Interpreting means understanding or figuring out what it's saying to you. Data to discover useful information. About drawing conclusions. And this is a long definition. I'm sorry. Okay. So basically, it just means studying your data and figuring out what it says. If you go to all the trouble to collect this data, you have to be able to read it and understand what it's saying to you. And bias is anything that sways an experiment, its results, in a way that makes them inaccurate. So to give you a very simple example, let's suppose that I'm doing an experiment on what kind of ice cream people prefer. And they can choose from strawberry, vanilla, and chocolate. So I'm doing just a basic survey on which type of ice cream they prefer. And I personally happen to hate strawberry ice cream. I just think it's nasty. I don't want it. I don't like it. That's a bias, okay? So I, as the scientist, hate strawberry ice cream. So in my experiment, I don't always make that an option. Maybe in some of the groups, they got strawberry if they wanted it, and then in some of them, I'm thinking, nobody's going to want strawberry. I'm not even going to put that in. That's a bias. Because I personally don't like something, I am not including it in the choices. That is an example of a bias. That is not true, by the way. I love strawberry ice cream, but that's just an example of how my personal opinion could get in the way of my experiment. And as a scientist, we have to avoid bias. And it's hard sometimes, especially if you're dealing with a topic that you feel strongly about. It's hard to not have bias in there, but you have to keep the bias out in order to make a valid experiment. Okay, evidence. I told you that I have a background in forensic science, so this one is dear to my heart. Evidence is information that supports or refutes a hypothesis. So let's suppose that there has been a crime and that the police arrest a man named John Doe for the crime. And so they bring in evidence from the scene to try to make the claim to the jury that John Doe is the criminal. And let's suppose that at the scene there was a drop of type O blood, and John Doe has type B blood. So would you say that the hypothesis is supported or refuted? In that case, it's refuted. It was falsifiable. It could not have been John Doe because the blood types do not match. So evidence is information that is scientifically collected that supports or refutes your claim. Reliable. Any evidence that you present has to be reliable. And reliable is what an experiment is considered to be. This is a long definition, I'm sorry. What an experiment is considered to be if, and I would write that in all caps and probably circle it, the same process. Remember, your experiment is a process. Can be repeated by other scientists. So we're talking about other trials of the experiment. To get the same results. Or with the same result. And I'll go back to my analogy of John Doe, my scenario of John Doe. Let's suppose that I believe John Doe is the criminal, and let me change it. Let's say Jane Doe. We know John Doe wasn't because the blood type didn't match. So we think it's Jane Doe. So I do a DNA test, and I take Jane Doe's DNA, I take the blood from the crime scene, and I match those DNAs. I think Jane Doe is the criminal. I've got information that supports that hypothesis. Another scientist should be able to take that same set of data, the two samples, and get the same result. And then a third scientist should be able to do that. And usually in a criminal case, you will have the prosecution's doctors to do the DNA testing and also the defense doctors to do the DNA testing. And those two doctors should come up with the same results. That's called reliability. If I can reproduce the same results over and over, I have a reliable study. And that's what we must have to base a science conclusion on evidence. Okay, in the next section, we will look at some graphs, so hopefully it'll be a little more fun. We do have definitions, but there's a little more in the next video. If you want to do more with this section, it's on pages 26 to 29 of the text, and I will see you in the next video.